need to coordinate between a weather API and a local AI assistant without writing separate connection logic for each. We'll show how FastMCP2's multi-server client lets you call tools and fetch resources across different servers, remote or local, using a single, unified interface. You'll see how server names automatically prefix tool calls and resource URIs, keeping everything clean and explicit.
Config equals MCP servers. Weather URL https://weatherapi example com/mcp. Assistant command python args/assistant server pi. Client equals client config. Async with client. Hash tools are prefixed with server names. Weather data equals await client call tool. Weather get forecast. City London. Response equals await client call tool. Assistant answer question. Question, what's the capital of France? Hash resources use prefixed URIs. Icons equals await client read resource. Weather //weather/icons/sunny. Templates equals await client read resource. Resource //assistant/template/list.
This demonstrates the multi-server client pattern with unified interface abstraction. The configuration-based approach lets you define multiple heterogeneous servers, HTTP, local processes, or in memory, under a single client interface, with automatic transport inference and namespaced operations. What makes this distinctive is the ability to interact with completely different server types through identical method calls, while maintaining clear separation between them via naming prefixes. The pattern works by establishing a two-layer architecture. The client handles protocol operations and namespace routing, while transports manage the actual connections. When you call a tool or resource, the client automatically routes the request to the correct server based on the name prefix, then normalizes the response format. This creates a declarative workflow where you specify what you need, weather data, assistant responses, rather than how to connect to each service. This approach solves the problem of distributed system complexity by providing a single control plane for disparate services. It's particularly valuable when building composite applications that need to coordinate between cloud APIs, local processes, and testing environments. The trade-off is some initial configuration overhead, but the payoff comes in reduced coupling and the ability to swap implementations without changing client code. Let's break it down line by line.
Config equals.
This defines the configuration dictionary for FastMCP server connections. It centralizes all server endpoints and launch commands, enabling dynamic tool routing at runtime. The structure follows FastMCP's multi-server configuration pattern for distributed tool execution.
MCP servers.
This defines the MCP server registry, mapping logical server names to their connection details. It centralizes configuration for all available microservices, enabling the client to dynamically route tool calls and resource requests to the correct backend. The pattern eliminates hard-coded endpoints, making the system more maintainable and scalable.
Weather URL https://weatherapi example com/mcp.
This configures a remote MCP server endpoint for weather services. The URL defines where the client will route all weather prefix tool calls and resource requests, abstracting the actual service location from the calling code. This is the standard MCP server declaration pattern for HTTP-based microservices.
Assistant command python args/assistant server pi.
This defines a local MCP server using process execution instead of HTTP. The command key specifies the executable, Python, and args provides the script path, launching assistant server, Pi as a subprocess. This pattern enables non-HTTP services to integrate with FastMCP's unified tool interface. This closing brace terminates the configuration dictionary, finalizing the server definitions for both the weather API endpoint and the local assistant process. It ensures the config object is properly structured before being passed to the client constructor, preventing any potential syntax errors during initialization. This closing brace terminates the configuration dictionary, finalizing the server definitions for both the weather API endpoint and the local assistant process. Without this, Python would expect additional key-value pairs, causing a syntax error. It's the required delimiter for all dictionary literals in Python.
Client equals client, config.
Instantiates the FastMCP client with the provided server configuration. This single client manages all connections to both the weather API and assistant service, handling connection pooling and request routing under the hood. The config dict defines available servers and their connection details, either as URLs or subprocess commands.
Async with client.
Context manager pattern for async operations. The async with ensures the FastMCP client connection is properly initialized and cleaned up, preventing resource leaks when the block exits. This is the standard way to manage async client lifecycles in FastMCP.
Hash tools are prefixed with server names. Weather data equals await client call tool, weather get forecast, city, London.
This invokes a remote tool named weatherGetForecast on the weather server, passing city, London as arguments. The server name prefix, weather, routes the call to the correct MCP server defined in the config, enabling distributed tool execution across multiple services.
Response equals await client, call tool, assistant answer question. Question, what's the capital of France?
This invokes the AI callable tool named assistant answer question, defined in the assistant server configuration. The dictionary argument passes structured input to the tool, enabling precise question answering while maintaining clean separation between tool definition and invocation. This pattern mirrors RPC calls, but with AI-friendly serialization.
Hash resources use prefixed URIs. Icons equals await client, read resource, weather, / weather / icons / sunny.
Resource URI pattern with server namespace. The weather / prefix routes requests to the weather server defined in config, preventing naming collisions across services. This enables isolated resource management while maintaining a unified client interface.
Templates equals await client, read resource, resource, / assistant / template / list.
This fetches a template resource from the assistant server using a URI scheme. The resource / prefix routes the request to the correct MCP server, while the path identifies the specific template. This pattern enables cross-server resource sharing without hard-coded server locations. FastMCP multi-server architecture. The client configuration demonstrates how FastMCP abstracts multiple servers into a unified namespace, where tools and resources are prefixed by server identifiers like weather and assistant. Prefix collisions silently fail, so always verify tool availability with list tools after connection. This pattern enables seamless integration of distributed services while maintaining clean client-side code.
The client that speaks to many servers hears only one voice.